Okay, so we are on day two, lesson 2 of module 1, and we are going to continue our talk of simple machines. So we had levers, we had different kinds, class 1, class 2, class 3 levers yesterday. Today we're going to talk about a wheel and axle and a pulley and the mechanical advantages with those. So I'm going to go ahead and get back into the slide presentation that we are continuing from. This right here is slide 24, and we'll go ahead and finish this out. So let me go ahead and present this so that you guys can see this a little bit bigger. So this is the idea of a wheel and an axle. We're all familiar with this. We've all been in a car before. It's that concept of having a mechanical advantage of some kind with a wheel and axle. I'm going to move myself down here just so we can see this one spinning. So we're going to learn that for this, when we have a, if we're putting pressure on the actual axle, when we put it on the axle, that's going to have a mechanical advantage less than 1. Remember how we talked about that? You'll see that in action. It's going to be hard to turn that axle. Think about a car axle. If you got under the car and you tried to turn the axle to move the car on the wheels, it would probably be impossible. I'm guessing you could not make that happen. We're going to see another example though, where when we grab a steering wheel in a car, so that's a different kind of wheel, right? It's connected to an axle as well. When we turn that, it's very easy to move, okay? So when you're talking about the outside of the wheels, that if you have that you're actually going to rotate, that's your effort force, right? My effort force is on the outside, then that is going to yield a mechanical advantage, okay? So let's go ahead and go to the next one. Let me see if I can do that. It's a little different when you're presenting on Zoom. It says, can you think of an example of a wheel driving an axle? So we already kind of talked about a couple examples here. We have a steering wheel, okay, where you're actually driving the wheel, the outside of it, and then the axle is moving. That's going to have a mechanical advantage. Here's another example in real life. You have this right here, which is like you spin it, okay? You're actually grabbing kind of on the axle, is that idea. But you're spinning it in order to start a washer or a dryer. Then there's this idea, again, you're creating that mechanical advantage of spinning to turn an axle to start a hose, okay? There's just a couple places that you see wheels and axles. There's many, many places that we see them. So when we talk about the IMA, remember it's I'm a deer. So you have DE over DR. I'm gonna move my picture again because just happens to be that in this presentation we have a lot of them up here. So if I'm applying my effort on the axle, that's what we see here. This is my effort right here. If I'm applying effort on the axle, so I'm grabbing the axle and I'm trying to move that instead, then what I would do is I would have my DE, my distance on my, so I'm talking about the circumference right here, right? I'm talking about my circumference. So I would take that right there. I'm going to actually do, so it has the 6 inches. So I take that circumference. That is going to be my effort, okay, my effort. And then I put that over the circumference of my resistance, If I'm putting the force on the axle, that's what I would do. So I would have 6, you can do the 2 pi r, those end up canceling out because we're talking about wheels for both of them. So the 2 pi r's end up going away anyways. So I literally am left with 6 over 20. 6 over 20. You can see how if I'm putting my pressure on the actual, or my effort, that's what I should be using. If I'm putting my effort on the axle, it's always going to be a small number over a big number. In math, that is going to give us a number less than 1. Let's see if it will give me the work here. If the axle, so what if the IMA, so we have here the wheel of the axle is driving, so we have the axle driving the wheel. Then it would be 6 over 20. We get an IMA of 3.3, or 3 to 10 is how I like to keep it, okay, 3 to 10. But we will sometimes see it as 0.3. Now, if we're doing the opposite, if we're using the wheel to drive the axle, we're going to provide a mechanical advantage. Then my effort is on the wheel, is on the 20-inch circumference, and that would be over your axle, over the resistance, which would be the 6. So in that one, you would have instead a 3.33 to 1. A 3.33 to 1. Okay, so that shows you a wheel and axle example. The actual mechanical advantage, you'd have to get the forces. Remember, AMA uses forces instead of distances. So in here, we'd have to get the actual forces. And remember, it's AMA free. My resistance is on top and my effort is on bottom. That's opposite when we're talking about ideal mechanical advantage. So on this one, if I have my force on my axle, okay, my force on my, it looks like actually here, we're gonna use the wheel this time, okay? Actually, let me see what they're doing here. Yeah, they're using the wheel on this one. So if we're using the wheel to drive the axle, then we have, remember if we're using the IMA, okay, IMA, dear, then you would be doing the 20/6, which we got that 0.33. Now we're going to use the forces. So I'm going to use my reaction force. So my reaction force is that 200 pounds down. That's the larger number, 200 pounds down over my axle, which would be 70. You end up getting 2.86 when you do that. 200 divided by 270 is 2.86 to 1. The way that we find out the percent efficiency we learned yesterday is to take your actual mechanical advantage and divide it by your ideal mechanical advantage. This number will never be 100%. There will always be an error because we don't live in a frictionless situation. So we take our 2.86, divide by 3.33, multiply times 100, and we end up getting that this machine, this wheel and axle machine, simple machine, is going to be 85.9% efficient. Okay, 85.9% efficient. You always want to see in the 80s, 90s, anything that gets into the 70s, you don't really like that percentage for efficiency. Okay, so now we're going to talk about a pulley. A pulley, so that's the idea of wheel and axle. If you're grabbing from the axle, you're going to have a mechanical advantage less than 1. If you're grabbing from the wheel, you're going to have a mechanical advantage greater than 1. With a pulley is a lever consisting of a wheel and a groove in its rim, and it's usually used to change the direction or magnitude of force exerted on a rope or cable. So this is a pulley system. I'm going to show you, here it gives you one in real life, but they're like trying to lift something up. This pulley is trying to reverse the direction. I want to be able to pull down for something to be able to come up. Okay, I want to, because this one only has 1 on it, and we're going to talk about that. That's going to be actually a mechanical advantage of 1. I have to pull down 200 pounds to lift up 200 pounds. But it's changing the direction. I'm no longer having to lift something up. I can pull it down and then it will pull something up. Okay, so it's changing the direction in this simple machine. Okay, so there's a couple different pulleys that you have. There's a fixed pulley which looks like this. This fixed pulley would kind of be like a pulley's at the top and you have this circular rope on either side, and it's going to pull something up and down. This is what we saw in the last picture. So if you have 10 pounds here, it's going to take 10 pounds of me pulling down in order to lift 10 pounds up this. Okay, so it's just really facilitating that change in motion. Okay, changes the direction of the force. The ideal mechanical advantage is actually 1 here. Okay, there's no real mechanical advantage here. But this one right here is known as a movable pulley. Movable pulleys are used in constructions a lot. So this right here is going to be attached here. And then it goes through here. And I'm still, in this one I'm pulling up. You'll notice it does not change the direction. Okay. This right here, I'm pulling up on it on this side and pulling this weight up as well. Now let me move this over. Let me go back really quick. There it is. It's pulling this 10-pound weight up instead. So I'm pulling up, but I'm only having to pull up with 5 pounds. So I'm pulling up with 5 pounds, but now because 5 pounds of force is directed in this direction and 5 pounds I'm directing, that's my effort force, I can actually lift 10 pounds. That's huge. That's going to be where we create a mechanical advantage. Our IMA here is going to be 2. Here, it didn't do anything for me except for change direction. Here, I have an IMA of 2 to 1. Okay, I can lift twice as much weight using this pole. pulley. Okay, there's a couple more of these. I do want to talk about the fact that in this one, we have an IMA of however many times it goes around. That's the important thing. It's the number of strands opposing the force of the load. That's how we do IMA in these ones. So IMA before was I'm a deer, DE over DR. But in this one, it's a little bit different. It's actually just the opposing forces. How many strands do you have opposing it? Okay, so in this one is going to be called, pulled. So I'm going to pull down, and it's going to pull this bike, this 600-pound bike up. That's what a pulley system does. When I do that, I have opposing forces. This one right here goes down. 1, 2, okay. I have 3 and 4, the fourth one. There's 4 opposing forces. You can almost think of it as loops, right? I have 1 on that side because then this one goes in that direction. I have 2 on this side, right here, I loop around. I have my second one right there. That one is opposing the force, and then this one's moving the direction. There's 3, and then obviously this fourth one right there, okay? So those are the pulleys. How many strands do you have opposing this force? 1, 2, 3, 4. There are 4 different opposing forces. So on this one, it should say that I have an IMA of 4. It did, right back here. There it is. Has an IMA of 4. Okay, so now we're going to talk about compound. So in this one, we have a compound machine. We have a pulley system right here, and we have here a lever. So the way that we're going to do any kind of compound is you actually just multiply your IMAs together. So the IMA total will equal to the IMA, okay, ideal mechanical advantage, of this pulley system times the IMA of the lever. So in this one we have forces, right? But I also have distances. So the thing that I'm actually given is I'm a deer, right? So I'm going to be doing the IMA. The IMA of a pulley is however many strands you have. Of opposing here. I have 1, 2. I have 2 strands here. So in this one, my IMA for the pulley is 2. Number of strands, 2. The IMA of the lever, remember, a lever is I'm a deer. Distance of the effort force. Here's your effort. The distance from your lever or from your fulcrum to that is 12 feet. 12 feet. So it's going to be 12 feet over your DR. Here is your resistance. That's your weight, right? Whatever weight you have. The distance there, they're telling us, is 4. So we have 2 times 3, we have 6. This right here provides a mechanical advantage of 6 if I have this system in place right here, which means actually, if you're thinking of that, it means that I should be able to lift something with 6 times less effort. So if I put a 6-pound weight right here, I should ideally, and again, this is no friction or anything, I should ideally be able to lift it with 1 pound of force. Okay, I do want to talk about the friction on pulleys. IMA on a pulley in real life, the actual mechanical advantage, so we have the ideal mechanical advantage. The actual mechanical advantage, a lot is lost on these. So I want you guys to know that. We're going to see this in class when we actually build our simple machines, but the actual mechanical advantage is actually pretty low on a pulley. And it's because think of how much friction you have between the rope and the pulley system. There's a lot of friction there. So your ideal is not actually going to happen, but pulleys do help distribute weight very easily. The reason you see these crazy pulley systems, like we saw in this one right here that had a IMA of 4, is because they've done all of this work so that way I only have to put in 4 times less effort, okay, to lift up that motorcycle. So I only have to go 4 times less effort to lift up this motorcycle. Okay, let me go back and finish this up with compound machines. This right here, in order to get the IMA of this kind of pulley system, okay, you've got your fixed pulleys right here. The thing that you would do is you would multiply the IMA 1 times IMA 2 times IMA 3. That's how you're going to get your ideal mechanical advantages. All three of those, you multiply those together. So in this case, what we have going on is we have a mechanical advantage of this one of 2, this one 2, this one 2, because remember it's the number of strings, 2 times 2 times 2, which will give you ideal mechanical advantage of 8. You get an ideal mechanical advantage of 8. It means that if you want to lift an 80-pound weight, you only have to pull up 10 pounds. Imagine how awesome that is when you're trying to move large material. Okay, is that all? I can't remember if, oh, here they're doing the IMA for, or the actual mechanical advantage of a pulley system. So they're using the same one that we were looking at before, except for it's an 800-pound weight. And here you have a mechanical advantage of 1, 2, 3, 4. So those are going to be your AMA, your IMA. Your IMA is going to be 4 strings. So now we're going to look at the actual mechanical advantage. In order to get that, you have to have the forces instead. So if I have 4 or 800 pounds of force, that's my resistance force that goes on top, okay? And it takes 230 pounds of me pulling down. It's obviously providing a mechanical advantage, or I'm sorry, in this one, yes, it's providing a mechanical advantage, right? I had to pull less than it actually weighs. Then I have over 230. So when I do that, I get an actual mechanical advantage of 3.48. That's not the ideal. Our ideal was 4 because there's 4 strings. So you can see that we end up with an efficiency of about 87% for this pulley, about 87% for the pulley. So that's the calculation part of it. Okay, I do want to talk about a couple of misconceptions. There's a misconception that when you angle these right here, when you angle these, that it doesn't do anything to the forces. It doesn't really make a difference. These are different strings, but that is incorrect. You can see here that you actually would have to apply more force, because think of it this way. Here, I could lift 80 pounds. If I lift it straight up, I could lift it with only 40 pounds. Here, to lift 80 pounds, if I pull this pulley out to the side, and now I'm like over here trying to pull it, I'm gonna have to exert 6 extra pounds to lift that 80. Angles do matter. It says common misconception. There it is. That is incorrect. So that's why we talk about forces being opposite or parallel to resistance forces. So that's really important for you to understand. We're not gonna do this kind of IMA, so don't worry about this IMA, but please know that it is gonna end up being different. Okay, and that's all I'm gonna go into for now. That was the last slide that I'm going to cover. Good luck. All you had to do today was take notes on that. Make sure you understand the concept of a wheel and axle. So brief overview I should do really quick. A wheel and axle, if you're applying your effort force on the axle, okay, you're always gonna have a mechanical advantage less than 1, okay? Whereas if I'm going to apply the effort on the wheel, if I'm going to provide it on the wheel, I'm going to have a mechanical advantage greater than 1. With pulleys, you will always have a mechanical advantage of either 1 or higher, because if it wraps around 1 time, you still have a mechanical advantage of 1. But then if you get more strings involved or more loops, you're always going to have a mechanical advantage greater than 1. So that's kind of the main concept of the day. Tomorrow, you guys are going to be practicing problems associated with both today's and yesterday's lesson. I also will be holding a Zoom meeting today, so if you guys would like to pop into the Zoom to see more examples of this, I'll definitely be going over that in my Zoom as well. Have a happy Wednesday.